My name is Steve Miller, a leader of the Building Electrification Initiative. And today we have a virtual panel of several presenters. And also I'm going to be tag teaming with my wife, Pat Miller. Each of you passed through our new requirement to first register. And the reason is a heightened security precaution since this event is widely advertised. After this meeting, I will use that registration information to email all registrants the links to the recording and the links to the slides that are shown tonight. So let me begin with just a quick introduction. There are three sectors that account for almost 90% of New Jersey's greenhouse gas emissions. They are transportation, residential and commercial building heating, and electricity generation from fracked gas. Transportation is the single greatest source in New Jersey. So the US and New Jersey have programs to convert their electric cars, buses, and public transportation. But the second greatest greenhouse gas source in New Jersey are all the homes that use fossil fuel for space heating and water heating. And that's about 80% of them are using gas and also using gas for cooking and clothes dryers, etc. And a total of 25% of New Jersey's greenhouse gases are from New Jersey buildings. And yet New Jersey has been dragging its feet and has very limited plans for buildings emission reduction before 2030. So the building electrification team now has more than 50 New Jersey business and homeowner members supporting the 2022 building electrification strategy of Empower New Jersey. That's a coalition of over 100 New Jersey environmental organizations. Our work is nonpartisan and it's not a mandate, which causes many people to rebel. So last fall, we requested, and Governor Murphy answered on November 6th, setting the New Jersey goal to halve greenhouse gas emissions by 2030. But our analysis shows that New Jersey will dramatically miss this goal if we don't start immediately to address greenhouse gas from buildings. So now I'm turning over the meeting to Pat for just a quick discussion of our 4 objectives. So Pat, go on ahead and share your screen.
Okay. There, can you see it?
We can.
Okay, so with Empower New Jersey, we have 4 objectives. The first is to work with all willing partners to develop targets for heat pump installations from now to 2030 and to 2050. We would love to use New York as a role model. Last month, the New York governor announced a 2030 target of 2 million heat pumps installed. New Jersey has about half the population of New York. So we would love to set a goal of about 1 million heat pumps by 2030. Heat pumps are simply an air conditioner with a few $100s of additional parts that also operate in reverse to provide heat as well as cooling. Heat pumps use electricity very efficiently. They will eventually replace fracked gas used for building heating. Today, the operational cost of heat pumps is about the same as the operational cost of fracked gas heating. So we will need adequate incentives for people to switch to heat pumps. Heat pump efficiency will continue to increase because of federal EPA standards, and the portion of our electricity that is from clean, renewable sources will increase as well to 100%. The second objective is to require increasingly stringent building codes to make new and modified buildings energy efficient, all electric, and net zero emissions. The International Code Commission, which is called the ICC, forms the basis of the New Jersey Uniform Construction Code, which in turn is adopted by New Jersey cities. It's updated every 3 years, and the ICC is on record to move to net zero greenhouse gas emissions in buildings by 2030. Our goal is to accelerate this code adoption in New Jersey. The third objective is to start now the New Jersey transition to heat pumps for existing residential and commercial buildings. Provide sufficient incentives and marketing to entice people to switch from oil, propane, even inefficient electric baseboard heat, and switch from gas heat to heat pumps powered by increasingly renewable electricity. Often this will happen upon retirement of the existing non-working air conditioner or furnace. And the fourth is to maximize customer education, marketing, and incentives for energy efficiency audits and improvements. The New Jersey utilities are now in charge of energy efficiency programs in existing buildings. Many of us are peeved that gas utility is allowed to heavily market and offer incentives for new gas appliances, especially gas-powered furnaces, boilers, water heaters, and such, which will continue to emit and pollute for their lifetimes.
Thank you, Pat. So today we have two distinguished speakers. First, we're featuring Hap Haven with the New Jersey Clean Energy Program. Hap has been on our previous webinars and he covers the most bases and is always one of our most informative speakers. So Hap will spend about 30 minutes discussing paths to a zero carbon home and will show us the steps residents can take to achieve net zero. Hap, the meeting is now yours.
Okay, that's wonderful. Thank you, Steve. And Pat, thanks so much for that wonderful sort of synopsis of where we are right now in the state. Let me get my slideshow up and running here, and we can get right into it. All right, so first of all, I just have to say I'm really excited about this presentation because it's the first time that I've sort of put together all the paths to zero energy, zero carbon. And tonight, I just want to say this is a high level presentation. And I say that because every slide that I'm going to show you tonight could in fact be a presentation all by itself. You could drill down into the details and spend an hour on every one slide, but it's a presentation about you and how you can make a difference, because some people, a lot of people think that, well, you know what? We're going to get there. We're going to get to this magical goal in 2050, okay? Because every year codes get better. There's incentives on the state side, on the utility side, and even tax credits on the federal side. So people sort of are in this malaise about, yeah, it's going to happen. The problem with that is the goal is way up here. And if we just track where we are right now, we're going to fall grossly short of that. And so what I say is we're at a junction right now, okay, because only you, okay, is, you meaning all the people on this call and all your friends and people that you know are going to be able to get us to that goal. And it can't be sort of like, oh, someone else is going to do it. It's like we all have to take personal responsibility and get going on it. So let's start talking about it here. Let me just give me a second here. All right. Sorry, I just have a big bar across the my presentation. It's hard to see it. So let me just say that every step you take, every action you take, okay, either brings you closer to what we want, which is that sustainable society, that zero carbon home, the zero energy home. It either takes us to that or away from that. So we're at a crossroads, right? Here we are, and we can take one road and go to sustainability, or we can go down that road, well, business as usual, and it's not going to get us where we want to go. So I ask you, what's your first step? And this is why I'm excited about it, is in 3 slides, I can tell you what your steps are. Okay, first of all, you have to choose a path, and there's 3 paths. The first one is buy a zero energy home. And I don't say this lightly. If you have the means to purchase a house, okay, you can go out into the marketplace and purchase a zero energy home that has all the bells and whistles that we want, okay, to move with the society forward. Okay, it's the fast track to get to that zero carbon, future that we're talking about. So that's one path. The second path is basically rebuild a home. We're talking about a gut rehab. And again, it's only for people who have the means to buy a new house. Or if you're going to do it on your own house, you're probably going to have to move out, for a year while this is happening, because it's really hard. I know I've done it, lived in it, and I wouldn't want to do it again. Where you're living inside of a house that is being ripped right down to the bare walls and re-engineered, okay, to be a proper new house that's energy efficient, zero energy home. So I can buy a brand new house, I can do a gut rehab of an existing house, or I can take the third path, which is the one that most of us are going to take, okay, which is basically upgrading the home that you're in, okay, and the upgrading starts with the shell itself, right? And the reason it starts with the shell and not the mechanicals is because the mechanicals, meaning like your heater and air conditioning, are sized to what the heat load is of the house, heat gain, heat loss. And if you were to put in a brand new system in your house that's sized for your house now, and then air seal and insulate it, you're going to be way oversized on the heating and cooling plant. So start with the shell, then the mechanical systems. And of course, appliances can happen anytime as you're going around. So, okay, we've got these three paths: new home, rehab, or upgrade. The beauty of it is the components and the efficiencies, okay, are similar no matter what you choose, what path you choose. All right. So let's talk about it. The first one is, if it's a new house, you should be buying an Energy Star house, zero energy ready, or net zero home. And if you do that, the process to make that house the way it is has integrated design and certification. And we're going to talk about that. If you're in your existing home, it's going to be an energy audit. Okay, that's the first step that you're going to take, no matter what path you're on. It's like, obviously you're just paying for it if you buy the new house, okay, and you're going to be owning it and working with it if it's in an existing home. The second step is to embed the solutions directly into the shell of the house. Okay, so what we're going to do is we're going to bake into the house the things that make houses efficient. Okay, and we're going to talk about each one of these as we go along. The third one is to install all the solutions into the shell, okay, meaning the heating, the cooling, everything else, the appliances, as most energy efficient as possible. So 3 things to look at, and let's get right to it. If we're going to do the certification and or audit, okay, both of those, okay, focus in on and embrace building science. Okay, and I tell you that building science first started coming along strong the late 70s, early 80s with the Weatherization Assistance Program. And we started codifying and putting the scientific method to, oh, how tight is this? Is that working right? It's come along. And I can't say enough about building science, okay, because if I was to take you to the hospital with a broken leg and say, you know what, we're going to take this tree limb and we're going to tie it to your leg, and that's going to be the splint for your broken leg. Well, that's kind of what's happening with so many builders right now all across the country. And that is, they've been building houses the same way since the 50s, the 60s, the 70s. The fact is that you should never have to put up with a contractor saying, oh, trust me, I've been in business for 20 years, because we have the tools to understand everything about the building. All right, so new homes in New Jersey are certified under the Energy Star program. Okay, we do that because over 3 million homes in this country have been certified through that program. That's like magnitudes, okay, more than the nearest competitor, which is like 150,000. So Energy Star, is a great way to start. There are definitely other certification, methods out there like Passive House and LEED, things like that, but they all rely on Energy Star, okay, and as a basic energy component. And in this state, you have to qualify through Energy Star, and we're going to be talking about the raters as we go along. In existing homes, an energy audit, the auditor should be a certified by the Building Performance Institute just like the HERS rater is certified by ResNet, the energy auditor should be certified by the Building Performance Institute. And the whole idea here is they're creating, whichever way you go, new construction or existing home, they're creating a roadmap to success. Now, when it comes to new homes, the roadmap is for the builder. When it comes to existing homes, the roadmap is for you or your general contractor, however that works. So let's talk about new construction. Okay, I said the home energy rating system, or HERS. All right, and that scale, okay, is just goes from 0 to 100 and beyond. Okay, but you can see that 100 is a code house built in 2006. And you can also see that down here, the 2018 code house, okay, has a rating of 70. It's 30 points or 30% better than the 2006 house. We don't want to be there. We want to be at the bottom of the chart. This is like a reverse chart, right? The lower you go, the better. So where do we sit for Energy Star homes? Of a score somewhere around 55 to 65. Zero Energy Ready is somewhere between 45 and 55. And of course, the Holy Grail, this is what we're looking for, are net zero homes where they have a HERS score of 0, right? And it doesn't mean they're not using any energy. It means that, net, over the course of a year, I use this amount and I generate that amount. So it's the same, the same amount. So the raters, what do? Okay, the raters work for the builder, okay, not for the homeowner, okay, and they help the builder understand how to maximize their construction. They do a pre-drywall check, like the photograph here. They look at the house before it's closed in from the inside. It's closed in from the outside, and so they look at the shell, they look at the framing, okay, and then they do a post inspection and generate the score for them. All right, moving from new construction to existing homes, the Building Performance Institute auditor is going to use home performance with Energy Star protocols. And by doing that, they're going to be able to tell you exactly what steps to take to re-engineer the home to be more comfortable, energy efficient, safer, healthier, more durable. These are the things that we're looking to do. Now, we're doing that in the new home or the gut rehab. It's just not involving you in the same way. And there's a link there I just put in. I put in like 6 links in the chat before we started the presentation. It has my email address, but it has a whole bunch of links to the clean energy program. Okay, this particular one is called Transition. It's the energy. The website is very simple, njcleanenergy.com. Okay, and if you want to find something / put in what it is, residential new construction, transition, whatever. But if you click on the transition one, it'll bring you to a web page that has every utility in the state and links to their programs. So if you're going to be doing a home performance job, okay, where you're going to do air sealing installation, new heating, and all that sort of stuff, you can find the program in your local utility. It was last July that the state divested itself of all existing home programs. I think Pat mentioned that, right? This is where you can get it one stop, and you can move forward from there. All right, now, as an energy auditor, if you've been around for a couple of years, you've done a couple hundred homes, you can walk into any house with a clipboard and just basically inventory the house without the tools. Okay, but you're always going to be using the tools. And I'll guarantee you that if you're good, you'll get it like 90-95% right. But you use the tools in order to guarantee that what you thought you saw was in fact accurate. And a good example of that is the blower door. It's the workhorse of energy auditing, and it can depressurize or pressurize the house, whichever you need, and find out A, exactly how leaky the house is, and B, okay, where the leaks are. Now, there's lots of other tools, but every energy auditor should be using, okay, a blower door, an infrared camera, a combustion analyzer, and a moisture meter. And the reason for that is because these answer the most important questions inside the house. Okay, and again, now this is like a week course to be talking about the tools, okay? But let me just give you sort of a quick picture of a great tool, an infrared camera, okay, used with another great tool, a moisture meter. I'm looking at this picture, it's a basement. This is a digital picture of the basement. What I want to know is, where is it wet, where isn't? I know it's wet in the back here where I'm putting my cursor right now. You can see that the parging here, the mortar is beginning to fall off there. You know that's wet. Well, where else is it wet? Use the infrared camera in combination with a moisture meter, and this is what you see. Blue is wet. Darker blue is wetter. And this is going to tell me one thing about the basement that is really, really critical in this particular house. And that is the water problem is coming from the bottom up on the front of the house. It's a subsurface water problem. I'm not going to be able to deal with it unless I go out and dig up the entire front yard. So what we say in the business is every pollutant has just basically three things. Okay, and if it's radon, if it's water, you know, if it's whatever it is, lead, it's like, I want to find the source. I want to remove the source. If I can't remove it, then I want to separate myself from it. In this particular case, we can do that, but it's going to be an interior treatment as opposed to an exterior treatment. All right, so that was the energy auditing side of it and the certification side of it. The second one is doing something, you know, where we're baking it right into the building, and those are called control layers. And you might say to yourself, what on earth am I trying to control? Right? Well, it's really simple. I'm trying to control heat, air, moisture, and the sun. These are the four things that I'm trying to control, and my shell should do it for me. Right? Now, everyone thinks about making heat and making cooling for the house, but it's the second step. The first step is to control the envelope. Then you can think about the second. Okay, here's a heat gain in the summer, heat loss in the wintertime. You know, this is what we're thinking about. And it's different depending upon the house, right? So if I have a brand new house, okay, there's things I can change. Okay, if I'm building a house from scratch, I can change its location. Is it built in Cape May, or is it built in Sparta, right? Big difference in terms of climate. Also, when I'm building a house, I can face it the right direction if I want to get the sun to heat the house in the wintertime and to turn my back on the sun in the summertime. Okay, I can also control how I create it. You know, is it a framed house, an insulated concrete form house? What kind of structure is it? Okay, so I can control all these things, and I also control how big it is. And so these are all things, new construction, I can control. Okay, there are some things though I can control. Okay, even after, you know, I build the house, I can control how leaky it is. I can air seal it. I can also insulate it better. Some insulation, like wall insulation, is a lot harder than basement or attic insulation. I can still do it though. And how the windows are shaded. These are all key things. Yeah, and it's kind of funny, you know, I remember doing an energy audit maybe 15, 20 years ago on a new development, great, beautiful house, had a great room, 2-story windows, and those 2-story windows are facing west. So every day about 4 o'clock, the room overheats, okay? And that, of course, is why we love to use mini splits in the industry, because I can air condition just that room, okay? And I can do it very effectively. But if the builder had thought about that to begin with, he could have baked in some of the shading on those windows even before we got going. All right, now, remember, we're an energy auditor, and this is a room, nice room in a house. It could be a second floor on a bungalow, could be a bonus room over a garage, but you'll see that it's under the slope of the roof. You look at it like this. The energy auditor has to look at it like this. The energy auditor has to understand the framing of every house, because without that, you won't know how to insulate it or air seal it. You look at this and you say, okay, oh, we have 2 attics behind those walls, okay? And I have a problem right there where I've circled the two joints, the connections between the flooring and the walls. Okay, and I'll tell you why. Here's that. Sorry, here's that on the left-hand side. You can see a close-up of that knee wall and how the air travels through it. When we talk about the control layers being continuous, this is what we're talking about. It's not continuous. There's a break in the air barrier here and the insulation barrier. And so the air from the cold knee wall in the wintertime goes underneath the floor, making the ceiling of the first floor cold, making the floor of this little upstairs room cold as well. I need to be able to control it. There's holes like this everywhere in the house. All right, the other reason that we need to do this is because moisture goes wherever the air goes. Well, moisture is lighter than air, so it goes up. But wherever the air goes, it takes it with it. And if I have holes in the attic floor, then the moisture from the house will end up in the attic. It's just, there's no and if or buts about it. It'll end up in the attic. If it's enough moisture, or if the attic is cold enough, we'll get condensation and we'll get mold. So it's as simple as that. And that's another reason why we have to control. Remember, I said air, heat, and moisture. These are the three things that we need to control. Sun, we need to control as well. And here's the sun low on the winter horizon, and it's coming into this solar hallway. It's penetrating way into the solar, into the house. And so it's heating up the concrete and the stonework and the brickwork, and that's going to help heat the house in the evening. Well, in the summertime, it's a different ballgame. The sun rises in the sky, and as long as you have a big enough overhang in front of these like French doors here, then the sun won't penetrate into the house at all, and we won't get that heat gain from the sun. All right, here's the last section, and in a lot of ways, the most important, because we're talking about electrification. Okay, mechanicals, this is what we put into the house. We're not, onto the house. We're not building it into the house. We're putting it onto the house. Heat pumps, okay, heat pumps that replace air conditioners and heat pump water heaters. Okay, we also have high efficiency appliances, LED lighting, induction cooktops, heat pump dryers, and I would submit to you that very shortly, your car or truck will be considered a high efficiency appliance for your house. And I'll tell you why. Because you're going to be charging it from the house. And in the case you have a power outage, the car or the truck will be able to power your house. So it's going to be a symbiotic, relationship like that. So let's let Michael get in here. All right. So, and then the last thing in terms of the mechanicals are active solar. So let's just get right into it here. Heat pumps, these are not your father's heat pumps anymore, if you know the reference. These are cold climate heat pumps. I would never recommend that anyone go out and buy a heat pump. You go out and you buy a cold climate heat pump. And if you want to know if it is a cold climate heat pump or not, you go to this website and it'll give you this list here on the bottom. And this list, you can search by brand and model number and every configuration you want to identify whether or not something is a cold climate heat pump or not. These are the people that control the industry right now. Okay, they're the people that say, yes, you are a cold climate heat pump or you're not. Okay, so let's look at it. A cold climate heat pump, most people are now very familiar with something called a mini split. Okay, a mini split is an outdoor unit that I show you here and an indoor head. These are the things you see in restaurants, and typically they've been just air conditioning that's been added on to solve a problem in one specific room. But you can also buy them as heat pumps, and you can also buy them as cold climate heat pumps, meaning that they give you heat well below zero, okay, in an efficient manner. This is a single zone. I got one thing outside, I got one thing inside. But newer ones, okay, are multi-zone. So I can have one unit outside and multiple zones inside. Okay, the Mitsubishi Hyperheat can do 8 different zones on the inside of the house with one unit on the outside. All right, let's talk about how the heat's distributed. I just showed you the typical wall mount here. Okay, and I think most people are familiar with seeing that mounted. They're rather large, right? And but they're going to get smaller and smaller, but still they're mounted there. But that's not it, right? You can bury something in the ceiling and do a ducted version, and you can put cassettes in the ceiling that go 4 different directions or 1 different direction. You know, it's like they're very flexible, or you can hook it up to an air handler on the right here, and the air handler would replace your existing air handler in the basement if you have a ducted system. So heat pumps are very flexible in terms of how to heat and cool your house. But that's where I have to kind of stop and just say, we have to remember what we're talking about here, and that is refrigerants. Okay, what we're doing is we're using a refrigerant, like in your refrigerator or freezer or air conditioner, to move heat from one place to another. That's why it's called a heat pump, right? We're pumping from one place to another. Okay, but it is something we need to keep in mind here. Okay, when we talk about global climate change, you know, the warming of the atmosphere and all that sort of stuff, you know, we're talking a lot about CO2, okay, carbon dioxide. The entire global warming potential scale is based upon CO2. It has a GWP of 1. Natural gas, which is what we're trying to replace, or methane, has a global climate potential of 28 to 36, in that range. Refrigerants, their global climate potential is in the thousands. So we don't want to be leaking refrigerant out into the atmosphere because it has a terrible consequences, okay? The EPA and most countries are working toward establishing the law that refrigerants moving forward have a global warming potential of 750 or lower. Okay, and they're out there. There's a whole bunch of them out there on the market, but most aren't used for various reasons. Okay, but at the very bottom of the page here, R32 is the one that's probably most commonly used, not much in this country, but all over the rest of the world, because it has a GWP of 677. So that's taking us where we want to go. But there's another step that we need to take in the marketplace, and that's this slide. And that is, instead of doing a traditional heat pump where we have a compressor outside and some sort of distribution inside with refrigerant lines, okay, that can potentially leak down the road, you have a single unit. It's called a monoblock, and it's a single unit outside that has the compressor and the evaporator, and only this amount of refrigerant, extremely small amount of refrigerant, because it's only going from here to there, back again, right? And it's not being carried into the house, and it's factory sealed, so it can't be screwed up in the field. So I'm going to submit to you that as we move forward, you should be looking for this, okay? And they have on the left, low temperature solutions, high temperature solutions, and hybrid solutions. Okay, so they have got something for everyone. The problem is that we don't have a lot of these in the marketplace here in this country. And I've been saying this all along. Our country is so far behind the curve than the rest of the world that we have to like hurry up, get with it. All right, I'm coming down the home stretch here. Let me just look at a retrofit. Okay, here's a customer that has a 96% gas furnace. They want gas in the house. You're not going to take this gas way out of this house. Well, that's fine, no problem. You replace the air conditioner and you put in a heat pump. Now what I can do is I can air condition, you know, like normal, but I can also heat on the shoulder months. I can heat into the fall and into the spring. And the changeover time from when I'm using the heat pump to where I'm using the high efficiency gas, you know, heater depends solely on the cost of the gas and the cost of the electricity. And it's a very simple formula in order to get the changeover. Okay, in New Jersey, the changeover now is somewhere around the high 30s, low 40s. Okay, but if you have higher gas prices, then the switchover point gets lower and lower, you know, below freezing even, or right at freezing. So this is another way we're going to go. And finally, in this section here, the heat pump water heater, which extracts heat from wherever it's located, like in the basement, and then it pushes the the cooler air to the outside normally. But you can put a duct on it with a damper. And in the summertime, you can bring that cooler, drier air into the basement and help cool your house and dry the basement all at one time. So let's take a quick look at why heat pump water heaters are so good. They're super efficient. All right, 3 times more than an electric water heater and 3 to 5 times better than natural gas. Now, cost is another story. Okay, but efficiency, okay, these are the numbers. And then, are they safe? Absolutely. No backdrafting possible with these units. You're never going to get CO in the house. They're extremely reliable. They've been around for decades now. They last longer than typical water heaters, okay, and they're good for the environment. And they're a good investment too. Okay, typically, let's take the high end. Okay, payback in 10 years. That's a good payback, okay? But it's a great payback if you use all of the different rebates that are available for them right now. So this is like a win-win, situation. So I, can't recommend it more. And I can tell you right now, it's like I have a solar water heater on my house. I've had it for years. If I was to do it again with the technology now, I would install a heat pump water heater instead. So just, all right, when it comes to all the other appliances in the house, the answer is just, as you need to replace them, take the next one up, buy a more energy efficient one. Okay, and consider heat pump technology. Okay, the heat pump technology is the game changer for us. Most efficient dryer, most efficient water heater, most efficient heaters and air conditioners. It's fantastic. So I think that we've got about 5 more minutes. Are we okay, Steve? This is about 5 more minutes here.
I've been monitoring for questions. I don't see any questions yet. So we need to decide.
So I can take the whole time.
Well,
So, all right. Here's one of my favorite appliances, right? Because people say, oh, I have to have that gas stove because it has instantaneous. I turn it up, it goes higher. I turn it down, it gets lower. There's no delay like with an electric cooktop, whether it's quartz or just standard electric. The induction cooktop does that. It's instantaneous, up and down, instantly variable. And the beauty of it, this is one right here, okay, is that when it's not in use, it's just like a continuation of the counter. You can, roll out your pizza bread on this if you want. And it looks like this up close, right? There's the control on the left, okay? And I can control from 0 all the way up to this scale, I think goes to 8, okay? I can do a power boost, which will boil water in under a minute. And I can also put it on simmer or melt. So I have instantaneous and variable heating levels. So highly recommend it to everyone. LED lights, I don't know if we even need to talk about these right now. They're sort of like the de facto light bulb. But if you're, I remember the hysteria around these, we have hysteria around everything in this country when it's first, introduced. I think everyone recognizes that they do a great job. You can get them a lot of different color renditions, and they're making fixtures, light fixtures that are radically different than what you could have with an incandescent or even a compact fluorescent bulb. All right, and if we would, there we go. And this is the last thing I was talking about, the car. All right, so people talk to me all the time about, okay, range anxiety. Range anxiety is you buy a car, but you drive more than that, than the range the car has. Buy the car that suits your needs, or buy the car that suits a limited amount of need, and then rent a car, okay, or take an Uber if you got to do something else, right? So that's the key here. This is the first generation, meaning it's less than 100 miles. Okay, now you're getting routinely 250, 300 miles on cars. But I don't care. I never have range anxiety because where do I go? I go to Home Depot, I go to the coffee house, I go downtown, I do whatever. It's like, I'm not driving, to Pittsburgh with this, right? So just buy what you need to buy. All right. The other thing, now we talk about solar. Okay. Zero energy ready is an interesting thing because it says basically, we're going to build a house ready for solar, but I'm not going to install the solar. But we have to make a distinction here as to what roof, okay, is ready for solar. This is a roof that is ready for solar. I can put a lot of solar on this. This is not a roof that I can put solar on easily, right? So we have to be smart about how we install our solar. This is not a good roof to put solar on unless I can get to that roof on the left some way. You see the front yard is sloping away. In order to service that solar panel, I'm going to have to do weird things like set the ladders on the backside of the house and come up and over. You know, it's just a difficult location. And the one on the right, okay, is beyond the pale. This is a 3-story house. So we're talking more than 40 feet in the air on a 12-12 pitched roof. If that roof has to be replaced or any servicing has to happen on the system, it's going to be a nightmare in terms of cost. Right. So it doesn't mean you can't get to it. It's just you need a lift. You know, you need a huge boom thing to be able to get to. All right. And solar water should be like this. This is mine, evacuated tubes. They're 1 story off the ground, easy to get to, easy to connect to the tank, which is, you know, only about 12 feet away. So solar hot water works phenomenally well. There's the panel from another direction. All right, so just to recap here, there's 3 paths to take, and I hope you're going to make a decision tonight as to which path you are going to choose. Okay, new, rehab, or upgrade. If you're doing the new, I highly recommend you get out there right now, even if you're not going to buy the house for another 3 years, because to move the market, we need people like you calling up, okay, the builder saying, are you building zero energy homes? And I can tell you right now, they're going to say no. And you're going to say, well, why not? Right? It's like, be the market, push the market, you know, forward. Okay, choose your path and get started. Okay, create a high performance home, whether it's a new home or whether it's the rehab. Okay, learn the science behind it, because you don't want contractors to be able to pull the wool over your eyes and test, because you can verify. It's like one of my colleagues says, proof is possible. It's like you can tell exactly how everything in the house is working. All righty. So that wraps it up here for me, Steve and Pat. Thank you so much for your time. In the chat, I put my email address as well as all the links that I have in the presentation. So, you know, please look in the chat and copy those things down.
I have one question for you, I think that you can answer pretty quickly. Are heat pump water heaters better than tankless water heaters? If so,
Well,
why?
Yeah. Well, they're different. Okay. It's like, if the tankless water heater is a high efficiency 90 plus, you know, instantaneous water heater, it's a phenomenal solution. Okay. They're small, they fit on it, but you have to understand that in order to put that into your basement, you're going to be spending the same kind of money that you're doing for a heat pump water heater. And that's because you're going to need a much larger sized gas line. So it's probably going to be a whole new gas line from where it came into the house to where the water heater is. And you have to clean it every year. If you don't clean it, you know, with a solution every year, okay, then it's going to get gummed up and it's not going to work for you over time. So it's a phenomenal product. And in some circumstances, I would recommend it. In other circumstances, I'd recommend the heat pump water heater. You have to understand the heat pump water heater is not going to work well for you in a closet on the first floor. It's going to work well in a basement that has a reasonably high ceiling and a lot of space around it. So like most things in life, okay, there's lots of variables and you would take them into consideration and say, okay, this is the one for me.
I have one question here from Michael Winka. Hap, how do you address the decrease in temperature in the winter if one puts their electric heat pump water heater in the basement? Should I uninsulate the hot water pipes and baseboard hydronic pipes in the basement?
Well, I don't know, Mike, if you've had the experience, but what I say to homeowners all the time is, do you use the basement? It's like, is the basement a basement or is it really a playroom and 3 other things, right? And because if you were to dump that air into the basement, it will cool it down a couple of degrees. So that's like robbing Peter to pay Paul. Now, cold air falls. So if you're not using the basement, it's not a problem. It's not going to affect your first and second floor. But that's why in the diagram I said, here's the simple solution. You vent the water heater, the heat pump water heater, to the outdoors. So the cool air goes to the outdoors and not into the basement. But you put a Y on it and a damper. And in the summertime, you throw that. So the cool, dry air, remember it's dehumidified. So the cool, dry air comes into the basement and cools and dries out the basement. So a simple ducting solution takes care of that, Mike.
There actually now are several questions, but I'm looking at the time, 7:50. Maybe these could be answered offline. Is that possible? And we'll just send out the answers.
No
offline?
trouble at all. It's like, send them over to me.
Okay.
And I'll answer them. And
Okay, I'm going to save these, and some of them are very good questions. I'd like to know the answers as well. So, because we need to get on to Scott, who's been patiently waiting. But Hap, I really appreciate that. We'll get the answers off to all the people that register. That's a big advantage of the registration.
Yes.
So next, we're very pleased to have Scott Nelson. He's an HVAC contractor, and maybe he can answer some of these questions, actually. He's the owner of a 25-employee Oceanside Services in Allenhurst, New Jersey, board member and past president of the Air Conditioning Contractors Association and the North version of that association. In a recent snowstorm, we had a few recently, Scott told me he has a fleet of 21 trucks and he has 4-wheel drive vehicles. He'll get to you in any emergency. So people like this you count on. So with that, I want to turn the floor over to Scott.
Hi, Hap. That was some great information, and thank you, Steve, for the introduction. What Hap brought up are really great ideas and great opportunities to get ourselves away from fossil fuel and go to a greener environment. But there's some things we all need to understand about making this jump as it comes to your mechanical systems in your house. First and foremost, as we're transitioning away from a fossil fuel system, is your electrical panel large enough to accept adding multiple heat pumps into your home? Yes, there's still, believe it or not, houses without central air that use window units. Traditionally, the mini split market has been a market that has been used to add air to a house that never had central air, and the byproduct is they have the ability to have heating with it. A lot of the older homes that would be retrofitted, whether it be from an old forced air system or hot water baseboard or steam heat, has sometimes limited electricity amperage in the home. So you have to take into consideration what size panel, what that cost of that upgrade is to get your home to the proper amount of ampacity as well as circuit capacity. System sizing, if we're going to do complete heat pump heat, sometimes is greater than the cooling needs, depending on the envelope of the house. As Hap talked about, sealing up that home to make sure that we keep the heat, the humidity, the sunlight from entering that house. When we're doing a rehab or we're doing a retrofit to a home, we have to make sure that if we're looking to size as consumers, that the contractors take into consideration the envelope of the home. And as the owner of the house, what are you going to do to make sure that envelope allows the use of electrical heating? We find a lot of issues where minimal insulation can't get to certain parts of a house, where people have gone in and put heat pump heating in and haven't used cold climate heat pumps, and they don't get the energy savings or the comfort that they expected. So it is important, as Hap showed the slide that has the service that allows you to find out if your contractor is sizing or providing a product that is going to be a cold climate heat pump, because there's a big difference. Mitsubishi's Hyperheat, Daikin has a line that as well as others that go down and give you heating capacity down to 15 degrees below zero, which is very important. As Hap showed the slides of all the different mini splits that are out there, there's multiple ones and multiple manufacturers. You have to be careful too. Certain ones have, if you go past 4 or 5 indoor pieces to one outdoor machine, you have to have a branch box. So you're now going to have multiple refrigeration lines running from multiple points, if it's a retrofit, down the side of your home, or perhaps through spaces in your home that are finished that will have to be covered, whether it be decorative boxing or a product that's called Slim Duck, which is a mechanical paintable raceway that can be used inside or outside. You want to make sure that it fits the decor and the look of what you want to do. They make low wall concealed units now that are great for one-to-one applications. They make low static, medium static, and high static air handlers. Low static are good for minimal duct runs. Static is the static pressure of the duct system. Medium static means you can run a little bit more duct work and feed more than a room or 2 or 3. High static is like the vertical air handler that Hap had in his slide that can replace your existing gas furnace in your house or oil furnace in your house to provide heat pump heat. But with that, you have to make sure your duct system is sealed. It's very, very important. There are products out there that can interior line the ductwork and air seal all the void spaces. Duct sizing is very important if you're going to go to a distribution system that you presently have and want to go to a heat pump. If your duct system is not sized properly, you won't get the delivery of BTUs you need to properly heat the house. So there's a lot of engineering that goes into having the right system for your home. Average life expectancy of a heat pump is half of what a gas furnace is, because it's operating, depending on where you live, it could be 9 months out of the year, 10 months out of the year, or it could be 7 months out of the year. Your traditional air conditioner is run from sometime maybe in May or early June, depending where you live, to maybe around Labor Day and then sparingly thereafter. Your heat pump is going to operate that much more, and it cuts down on the life expectancy. So that is also something you need to consider when you're making this kind of a purchase. Houses with hot water baseboard heating, houses that have steam heating. If a retrofit is not available, I know as Hap showed in his slides, there are these package systems that are going to be coming our way probably within the next 10 years into the United States. Our federal government has kind of stymied a lot of the inverter technology to making its way for lobbyists and self-serving purposes. Inverter technology was really kind of forced on the manufacturers because it was so popular around the rest of the world. Within 10 years, pretty much every unitary product, which is a household piece of equipment, will have an inverter compressor in it, whether it be a slimline mini split type system or an inverter unit in an actual unitary system like you would have for central air conditioning for your home. Those inverter compressors are very efficient and once again will provide cold climate heat pump technology. One of the bigger things to push this along is the industry needs to get into the ears of the architects, because somebody that does do new construction HVAC, I get very few homes that come my way where the equipment is spec'd for a cold climate heat pump. And 95% of my industry, unfortunately, only installs standard efficiency equipment, because they're just not. My industry is filled with people that are 2, 3, 4, or 5 trucks. The 95% of our industry is below 10 vehicles, and there's just not enough time to run and manage a business and manage his employees, because more than likely the owner is actually working out in the field. So there's not a lot of time for training and whatnot, and our industry is lagged way behind. That's why ACA, we promote training, manual J, D, and S, which is duct sizing, design load, and equipment selection, so that the end user gets what they paid for, but also gets the most efficient system. And it's very prevalent to do proper design selection and heat loss, heat gain on a heat pump, because your heat pump selection may be, as Hap said earlier, may be different in Sparta, or it's going to be different in Sparta than it's going to be in Cape May. It's such a complex thing, but very simple at the same time. But unfortunately, there's not a lot of people in my industry that have taken the time to learn it. When I broke into this business in 1981, we had just come off of living better electrically that led up to the 70s. And then I spent the next part of my career removing all those dogs of inefficient heat pumps, because they were backed up below 40 degrees. We lost the ability to get heat energy, and it had to be backed up with electric resistance heat. And when people got $1,000 electric bills, it was a panic. And as natural gas went to other parts of the rural parts of our state, that's when they made those conversions, or they went to propane. Heat pumps of today are completely different. You can get 100% heating capacity well below zero. So we need to push the architects to spec it. We need to, which falls on my lap and my associate's lap at the ACA level, state ACA level, is to better educate our people that work in your homes to be able to offer the proper cold climate heat pump solutions that that heat your home. There's been a lot of disasters out there, and I want to make sure that we're along everybody that's on this Zoom call understands it sounds very simplistic, but there's a lot of things that go into it to make it work. And with that comes cost. If you have to retrofit your duct system or run refrigeration piping through 14 or 16 or 18 rooms, they're not building houses that are any smaller. Everything seems to be bigger and bigger. And so there's just a lot of things that you need to take into consideration when you're thinking about hiring a professional to do it, and their knowledge base to understand your needs and the needs of the product to work properly for you. Does anybody have any questions?
I think I have some questions I'm looking through. Hold on a second. So one person asked, the fossil fuel industry has been advertising that heat pumps will not make you comfortable. They fear this is a competitor. Can we do anything to answer that fossil fuel industry issue?
Well, that's coming from the lobbying power of that. The gas company doesn't want to not be able to sell natural gas, and so that's where that comes from. We just finished a house, in the process of finishing it in the town of Deal, right on the ocean. It's a 16,000 square foot home that is no fossil fuel heat in it at all. 100% Mitsubishi hyperheat heat pump systems. And we had some pretty cold days this winter, and that house was to temperature every day. So I just had a blueprint that came across for a house that's being built in Seabright that's going to be net zero home. Tesla roof, batteries to store the power, all inverter heat pump for heat, heat pump water heater, all electric cooking, zero fossil fuel. We've done some hybrid houses that have used a combination of some gas heat and heat pump technology with utilizing dual fuel. And dual fuel, as Hap spoke about earlier, and creating a balance point, that's really based on the envelope of the house and the BTUs that heat pump can deliver. So there's a lot of decision making that goes into creating that balance point for it. But it can heat your house fine as long as the envelope situation is addressed.
All right, I appreciate it very much, Scott. We've gone over our 8 o'clock time, and now we could open it up to just general questions. I do have one final thing to announce before we do that, though. We actually will have our next general meeting in 1 month on March 17th, but in the meantime, we have some work group meetings. And so I'm calling your attention to chat. It shows that what we're trying to do is to create, along with the objectives that we have defined, we're trying to create the actions that go along to meet the objectives. And I have a request. If some people could take a look at the chat and help us with edit the document that's online, we'd like to then put all the comments together to work on the actions within that document to create a straw proposal. And so take a look at the chat. I probably will forward this again tomorrow, mostly to the building electrification team, but for other people on the call tonight, if you're not part of the building electrification team and you want to join us, let us know. And you're welcome to help us contribute to this document that's defining our charter in support of Empower NJ. And we're going to be trying to influence the state of New Jersey. So that's about my sales pitch for that. I'd like to then turn the questions to questions and answers for the next, I guess, 10 minutes. There are a series of questions. You know, what I could do is turn on all the mics. Would that be helpful?
Well, I know, Steve, I saw one question in the chat that is really important, and that is one of the benefits of having it, what I proposed was an induction cooktop, but one of the important reasons for not having a gas range or oven, okay, is that of the pollution that comes from it, the particulate that comes from it, you know, whether it's natural gas or carbon monoxide or just straight up very small, what they call PM2, extremely small particulates, okay, that are not good for your health. We've been in this country for years where houses have had kitchen ranges that just installed that just recirculate the air, which is fine for taking grease out of the air, but it does absolutely nothing for carbon monoxide, does nothing for the particulates, the sulfur dioxides, or any of those things. If you are cooking with a gas range or oven, you really should have a range hood that will capture all of the pollution and push it to the outside, and you run it whenever you're cooking. That's from a health standpoint, it's the studies on this are like very, very clear. The health benefits of having either a range hood that exhausts it, okay, or not cooking with gas.
Hap, can I just touch on that as well?
Yeah, jump in.
The code now requires makeup air. If you get past a certain amount of CFM removal on that hood. So when you're buying these extra large ranges that everybody thinks they're Julia Childs,
Yeah.
that if you go above a certain CFM, you're now going to create a negative pressure in your home, and you're going to have to recover that air. That's something you have to think about when it comes to building envelope.
Yeah, I think that the cutoff is 400 CFM, and
it is 400.
Yeah, but they make range hoods all the time that are like 1200 CFM. You know, it's like, oh, there goes the cat. You know, it's like very powerful commercial ranges, and they have to have makeup air, as Scott's saying, so that you're not depressurizing the entire house. Scott, oh, sorry. Let me just say, Scott, can you put in the chat your contact information?
Yeah, I put it in the chat already.
Okay, great.
Because that was office number and my email.
Okay,
there's a question from Mark Hackler. How do you compare cold climate heat pump efficiency to that of a gas furnace? I heard of a Daikin heat pump with a gas furnace backup. Why would I do that if the heat pump is comparably efficient at 0 degrees Fahrenheit?
For actually a couple of reasons. Depending on the efficiency of the gas furnace, we happen to be a Daikin dealer, so I'm very familiar with their products. Daikin has a gas furnace that's 97% efficient, that modulates. It's a very efficient gas piece of heating equipment. But depending on how the house is sized, that if it's got central air tied to it, that central air conditioning unit may not be big enough to meet the house's heating needs. So that's why you're going to run that heat pump as a dual fuel, and then have that changeover go to where it's giving you the extra BTUs you need to heat the house in a colder area. And depending on your electric and your gas rates, they may be one may be cheaper than the other.
I can't say enough about the Daikin equipment. It's fantastic. And I know, Scott, you're a rep, aren't you?
Yeah, we're their second biggest dealer in the state, and their technology, their technology, they're the largest HVAC manufacturer in the world, and I'm not doing an infomercial for them. They are that good, and their inverter compressor is the most used in the world, and they've been doing inverter technology forever. They actually own R32 refrigerant, which I talked about earlier. So they know it. They know it very well. Their technology. In fact, I'm going next Wednesday and Thursday down to Houston to their facility. My son, who's in my business, and they have a 5 million square foot manufacturing facility in Houston, and they're really light years ahead of most of the other manufacturers.
And it'd be wonderful to see their equipment more in this country. I know you're familiar with the Altherma unit, that which is it's an air to water system, like I was describing earlier on, and it was used for like a heartbeat, like just for like 6 months in this country, and then but it's installed everywhere in the world, but not here.
For reasons that are greater than all of us on this call.
That's right. Yes.
I turned on audio and video for those people who would like to raise additional questions. Just turn on your audio, especially, and pipe in.
I want to know if Alan Spector, if that's your actual house.
What was that to me? I'm sorry.
No, Alan Spector. I'm seeing Alan here.
Yeah, that is my house, and I'll be presenting. It has some enhancements since that time. That's an earlier picture. So we added solar panels since then. Yeah, so I have my home in Lafayette, New Jersey is an example of pretty much all the things you talked about. And I put them in over a period of like 15 years or so. So I'm totally net zero now with the electric car. So next week, next month, March 17th, Steve said I'll be presenting at 7 o'clock. So I'll have a slide presentation.
Right. So tune in on March 17th at 7 p.m.
Hey, I didn't know that. But it was a great lead in. I'll be here to listen to it.
Great.
I know Michael had a question. Electric baseboard resistance heating should be phased out. It truly should. It's beyond wasteful, and it's not something that you'd want in your house. And what's also nice with the ductless and ducted mini split technology is that you can heat room by room, which is very advantageous, especially as you watch the sun rise and set during the day. Your needs of heating and cooling change as the day progresses. So your heating needs at one end of your house in the morning may be completely different than it is several hours later.
Mike Winka had a question. He has his hand raised.
So can you hear me?
Yes, we can.
Oh, good. So just to add on to that, since both of you have infinite knowledge and experience with building codes, that seems to be the strat. How do we get our arms around changing those building codes to address heat pumps in new construction? At what point do you see that happening? How would you see that strategy playing out in terms of upgrading the code to, I don't know if it's requiring it right away or if there's a phase in for heat pumps over a period of time, but that seems to be the strategy that we need to get our arms around.
Well, it's interesting you should say that, Mike, because I was talking to Dennis Hayes recently, if you know, the father of Earth Day, and I was asking him about how do you how do you make progress? And, in a state, and, is it as incentives? Is it the carrot? Is it the stick? What is it? And he said that I've been in the industry so long, I'm beginning to think the only way to do it is just to regulate it. So Mike, you might be on something there. The biggest issue is that when it comes to building codes, okay, there's a fair amount of pushback from all kinds of industries. And I'll just give you an example. In the 2018 code, it requires, the code itself says you must test for air tightness in the house and the duct systems. And the powers that fought against that dumbed down the language to you must inspect for air tightness in ducts and the house, right? And that's a huge difference. And it was funny what Scott was saying back when he started working the industry, that the interesting ways that they would do a manual J for heat loss, heat gain, and one of my favorite is watching a contractor stand at the curb of a house. And Scott, you probably know this, and you hold a finger up. And if I can, from 50 feet away, if I can block the house, that's a 1-ton house. If I can block it, it's a 2-ton house for air conditioning, right? So that's literally a rule of thumb, right? And we're beyond that, right? We're beyond that. We can calculate these things, 5 ways to Sunday and do it inexpensively, but you have to have the rank and file that will actually do it. And Scott made a really good point. There's right around 9,000 HVAC contractors in the state of New Jersey, right? And most of those are smaller guys, and with just a few trucks. And it's hard to be profitable at that level and do all the extra stuff that you would like to do. So,
and if I can just kind of tie into that, these purchases, unfortunately, the bulk of the time are made strictly by a dollar amount. And, it next to the construction of your home, the next most important thing is your HVAC. And the problem is you don't get any social mileage out of that. Maybe some people in this group that want to show off their new energy efficient equipment because they're into what we're all discussing tonight would get that. But there's no social mileage on heating and cooling, and generally it's made to be purchased at the cheapest bid, and it's the most important thing that you're buying. It's a quarter or less of what you pay for a car, and you use this much more than you ever do your automobile. But people forget that they lose sight of that. They just lose sight of an actual dollar amount. And a company like myself and other ones, out there need to make sure they impress upon the homeowners and the business owners that, there is a cost benefit to doing this, as well as comfort and safety. And also, there's a bigger thing here, is lowering our carbon footprint as well.
I thank you very much. So we'll plan to get these questions answered and then send them out. There's still a series of other questions. We were trying to aim for an 8:15 close. We have 47 people still on the call, though. If people are willing to sit it out, do you want to continue answering questions? We can have a mutual agreement.
I'm good for a little bit longer.
A little bit longer.
Whatever you need.
I have a question about siding. I have to get my siding replaced. So how do I find information about a net zero siding?
Okay, well, siding is only one component of a wall, right? And it's the rain barrier to the wall, but there's other control barriers behind it. And so if you're just trying to replace the siding, there is no, energy component associated with it. But if you're going to do what we call in the industry a deep retrofit, which is you're actually going to deal with the wall itself, there's all kinds of fantastic products that will make your house more airtight and insulated properly. it's a huge question you just asked, but if you're dealing just with the siding itself, there really isn't any energy component to it. And for those people who have ever either looked at or considered buying a vinyl siding that has insulation, like a sandwich of insulation on the back, there's very little actually energy component associated with that, because siding is not meant to stop the rain from getting to what's behind it. It will slow it down. It'll definitely make less water getting through it, but water will get through. And so siding traditionally is always held off the wall, by a 1/2 inch or 3/4 inch furring strip, which allows water that penetrates behind it, okay, to drain out of the wall assembly. So, and so that's a control layer behind the siding. And if that's open to the outside, then cold air, warm air can get behind the siding, which you want, because you want to be able to dry that cavity out. By having something that is marketed as airtight as the siding and insulated as the siding, it's just not what you want. What you really want is the siding to stand free of the wall. Does that even come close to answering your question?
So where would I get information about that shell? How it has to be? And are there contractors who do that kind of work in New Jersey?
Yeah, there certainly are contractors like that. But if you're trying to educate yourself, I would go online to the Building Science Corporation. They're out of Boston, and they have a whole lot of books that have construction details and explanations of how to do it right. So it's sort of like protect yourself, right? It's like beware the buyer beware sort of thing. It's like bone up so that you understand what it is that you really need and want for your house, okay, and then go looking for it.
There was another question very similar. Where can you find certified energy auditors for guidance? And do you have advice about insulating underneath a residential flat roof? So it's a similar question, I think.
Okay, well, let's deal with the energy auditors first. Back before July of last year, I could tell you exactly where to go, because as part of the state, we had a listing of all the home performance contractors in the state of New Jersey, and they all had certified energy auditors. Now it's a utility by utility thing. So I think go to that, the website that I showed you. It was njcleanenergy.com/transition, and find your utility. And then we have two listed. One is commercial, the other is residential. Go to the residential list, click on the home performance program, and see if they have their energy auditors listed. If they don't, then you can go to the Building Performance Institute, BPI. I think it's bpi.org, and they have a listing of all of their energy auditors around the country. So if you didn't write that down, just drop me an email. I'll send you the link.
Could you do me a favor though, Hap? Just
Yeah.
give it to me, and then I'll send it out tomorrow or Saturday.
No trouble.
Okay, thank you. The other question was having to do with your slides. Somebody was asking to use your slides. Are you going to distribute those slides?
Actually, I'm not, for a very strange reason. Okay, normally I'm presenting through Clean Energy Program, and we have approved like slide decks. This is not a BPU approved slide deck, so I can't send it out. What I'll be doing, and it'll take months, what I'll be doing is I'll be taking this presentation that you saw tonight and sending it to the BPU for their approval. And because I think it's really important that we get this word out. I mean, there were 61 or so people on this call tonight, but how many people are living in New Jersey? I mean, we really need to have this information more widely distributed. And so I'm very anxious to see if we can get this presentation, in more areas. And I'd love to share it. Normally, like this, I did a presentation at noon today, and we just like make the well, we don't send out the slide deck. We send out the the PDFs, of it. I don't think we've ever approved the actual PowerPoint presentation, but we send out the PDFs of it, immediately to everyone. If you have a specific organization that you would like to use the presentation for, like a Sierra Club, like a Sustainable Jersey or whatever, let's just talk, but I can tell you right now, it's going to be a little while.
Okay, we still have 41 people hanging in here. We have many more questions. Should we continue? Would you like to continue?
Yeah, let's stop at 8:30.
Okay, 8:30. A very basic question. Who sells cold climate heat pumps and who does energy audits? Where do people go?
Well, Scott, you can answer about the cold climate heat pumps.
You could go to, you could just Google ductless mini split or heat pump systems. Not a lot of my people in my industry are advertising it because it's really not something that's at the top of everybody's list because it's not driven by a huge demand. This is the minority, as Hap was saying. There's how many people are in the state of New Jersey, and there were 60 or so people on the call tonight. It's almost every HVAC contractor will sell and install ductless mini split heat pumps. It'd be your job as a consumer is to quiz them on what their experience is, and then do your due diligence on the product that they offer, their sizing techniques, their whether they're in good standing with the Better Business Bureau, and their ratings through any of the rating sites. Some of those are subjective, but most will sell it. There's not a ton of us though that are as well versed in it, unfortunately, and that's part of my job on the state association is to make sure that we're doing a better job of educating our contractors.
Yeah, I think ACA and the state and a lot of the organizations are just sort of on the ground floor of promoting this technology. And I just, I think about, well, here's two great examples. One is the first LED spotlight that I bought. I paid $125 for it because it was the first, right? Now you can get a 65 watt LED for like $4, right? So, and that's the market, penetration, that's really huge. The first solar system I installed, I was selling it for like $15 a watt. Now you can get it for like $1.50 a watt or $2 a watt, in that range. So, as this market matures, I mean, Steve and Pat are sitting there, and we're all going to get old together, pushing, pushing this technology because it's not fast out of the gate, right? We can certainly do some things immediately, but there's a whole lot of mechanical, lobbying, and education that needs to happen. And I really am behind ACA and the work they do in the state here. So, hat off to you, Scott, for taking that on.
Thanks. 24 years on the board of directors, so it's a long time.
Someone was asking about building codes earlier. I was just asked to join the board of directors of the American Institute of Architects here in New Jersey. And one of the committees I'm going to sit on is the code committee. So hopefully we're going to be able to, push codes forward using the power of the organization, right? And the Sierra Club, I don't know, Steve, Pat, does Sierra Club have a code committee?
Not that I'm aware of. Maybe we could create one. Should we?
A code committee? What do you mean by a code committee?
It's a committee that will eventually give comment to Department of Community Affairs about the next adoption of code. The next cycle is the 21 code. Usually you adopt a year or 2 years after the code actually comes out. And so DCA is now in the middle of considering what should the next residential building code in terms of energy be, right? And so if the Sierra Club had a committee that could work with DCA, that would be helpful.
Well, we have staff, we have a conservation committee, and we have a legislative committee. That's the closest that comes to mind.
And we got a building electrification team, right, Steve?
Yeah,
We do.
yeah, that's
we
that's
could
the one
actually-
that,
We could create
And
a
we have
actually,
subcommittee.
people-
I stand corrected, Greg
School
and
bus.
Steve both, yes. Perhaps, Steve, maybe your committee could make some suggestions down the road?
Yes, I've been thinking, we have a very large committee and we could have a sub-team interested in the codes. And that could be used to provide comments back.
Just so everybody knows, Rich Isaac is our director for the New Jersey Sierra Club chapter.
Chair,
That's
we
why-
have a chapter director, she's staff, but yes, I am the chair.
So
I have
thank
a
you.
I have a
Question.
general question. I had a heat pump recently installed. How often should it be maintained? I was advised at the end of the heating season, at the end of the cooling season. Does that
That's
sound
what-
about right?
Yep, that's when it should be done.
Okay, great.
My name's Stan Graberis. I just have one comment, and that is, Hap, thank you for that invitation. That is very exciting, and we're very glad that you're going to be part of that committee. It's the foundation of where all the problems start. That's literally, everyone builds the code. And if we can impact the code, boy, we could speed this up. So thank you.
I did have one question on the codes, actually. Sorry to interrupt, but which where in the government handles the codes? Is it the DEP? Is it, where is it? DCA,
DCA.
okay. Got it. Okay, thank you.
Department of Community Affairs.
Sure, all right.
So I have another question. NEEP provided a presentation about a month ago now. They were developing with BPU and the Rutgers Green something or other sketch
Infrastructure.
codes for building electrification, zero energy. Will they need some kind of special legislation to push that through, or would that just be added on under the normal process here in New Jersey?
Yeah, it's going to be very difficult to push that through anything because the gas lobby is so strong. I think the best thing that can happen is to be able to educate the public, okay, about heat pumps, about cold climate heat pumps, and let them compete in the marketplace. Okay, because they win in the marketplace in so many ways. So, I'm not, it's funny, I'm not a big regulatory person. I would much rather let the marketplace, take over where it can. So let's work to make sure that everybody in the state knows that. And I said this in one of my slides, it's not your father's Oldsmobile anymore, right? That old commercial, it's like, it's when people say heat pump, they go, oh, well, that doesn't work. They just dismiss it because they're used to heat pumps from 20 years ago. And what we need to do, and the manufacturers should play a huge role in this regard, okay, should be out there beating the bandwagon saying, this is a great alternative, to a gas heater. Okay, and especially in new construction, because in new construction, I could build that house tight and insulated that, well, I was talking to someone last week where they said that they were going to heat a passive house with the equivalent of a hairdryer, right? It was 1200 watts. And so it's like, we can build homes. That's why I was talking about the control layers. If we build homes right, it's like, you don't need to have, big heating plants in it anymore. You need to deal more with fresh air, dehumidification, and a little bit of heating, a little bit of cooling, right? But that's new housing, right? There's 10 times more existing homes in New Jersey than new homes, right? So it's like we have to deal on both sides of the equation.
I think we should squeeze in one more question and then, because he's patiently waiting, David Pringle, and then call it quits for the evening. I appreciate
I see
all your
David
time.
there.
So one, I want to thank Sierra Club. You guys are kicking ass and taking names. For those of you who don't know me, I wear many hats. I'm mostly on this call to learn, but I wear Clean Water Action hat, Empower New Jersey hat. Sierra Club is leading the way on building issues right now, and we need to do a hell of a lot more. I'm on the steering committee with on Empower New Jersey. So I just want to thank you guys for pushing it forward. And whatever you think of the Murphy administration and how well they're doing or not, DCA in building is really backwards, and they are the biggest problem. So thank you for pushing it forward.
Thank you. So I appreciate the time everybody spent, and I'm sorry Greg and others have been waiting to present. Will be deferred to March 17th. We have a half dozen speakers talking about their personal experience with heat pumps, including me, by the way, and I'm eager to talk. So yeah, thank you for being here tonight for us. We'll get out the video link in a day or two and answer whatever questions we can as well at the same time.
Thank you.